Let's look at one more example from 9-2. If you totally understood what was going on from the last video, you don't need to watch this one. It's going to be very similar, but let's try to go through this one a little more efficiently and just do the whole process start to finish. Okay, so this is number 12 from the homework, and it's got a randomized controlled trial for bed nets to reduce malaria, which is a huge problem in the developing world. So let's, eventually they want us to test the claim. So I always like to start by figuring that out. Eventually they want us to test the claim that the malaria rate's lower with the bed nets, which makes sense. So let's go back through and see what our groups are. We've got infants using bed nets and infants not using bed nets. Okay, so we can jot that down. So we got the bed nets group and we've got the no bed nets. Okay, for the bed net group, 343 infants and 15 got malaria. And we'll call that proportion 1, since they mentioned that first. For the no bed nets, it was 294. And 27 got malaria. So we want to test the claim that the incidence of malaria is lower for infants using bed nets. So the bed nets was group 1. So we want to test the claim that P1 will be less than P2. And again, the claim's not about this particular sample. It's about the population. So is this sample convincing that the rate really is lower for bed nets? Okay, so P1 is less than P2. The opposite claim would be P1 greater than or equal to P2. There's that or equals to, so there's the null. And there's the alternative. And we are ready to grab stat disk. So first of all, the claim is that P1 is less than P2, so population proportion 1 less than population proportion 2. That's already what we want, left over from the last one. Significance level is 0.01 again. Sample size for group 1, it was 343 babies and 15 successes. And 294 babies in the second group, and 27 of them got malaria. All right, let's evaluate and see if there really is a difference here. The p-value is 0.0037 or 737. So the p-value is 0.00737. That does mean that our sample's unusual. Which means we get to reject the null. Which in this case is good news. That means that the alternative is true. It means that the incidence of malaria is lower, for instance, using bed nets. So there is evidence at the incidence. Incidence is like a medical word mostly, just about like the rate of something occurring. The incidence of malaria is lower for infants using bed nets. Okay. Let's go ahead and take a look at the appropriate confidence interval too, which is already sitting right there on StatDisk. So the confidence interval is essentially, let's see, about -9% to -0.1%. Let me jot that down. -0.09496. Okay. I'm not going to be able to remember that, but I'll give it my best shot. -9496. Let's see, did I get it? 0.9496, yep. And to -0.00125. Notice while there is a range of possibilities, the result is definitely negative. That means group 1 is definitely less than group 2. If you want to be a little more specific, you can say the incidence of malaria is anywhere between 9% lower, and again the lower is because of the negative. It says group 1 is smaller. Anywhere between 9% lower and, again, move that decimal place to over 0.1%. It's still negative, so it's still lower. It's lower with bed nets. This is a little bit more work to interpret than the hypothesis test, but it also gives us a little more information. The hypothesis test just said, yes, bed nets work. The confidence interval is saying, and here's how much they work. Here's how much they help. They reduce that rate of malaria by maybe by 9%, maybe only by 0.1%. Even 0.1% would be worth it with the number of kids that are getting malaria worldwide. But hopefully it's more than 0.1%. It'd be great if it was more toward the 9% side of things. Okay, I think with those two examples, you're ready to tackle the homework. As always, come at me with questions. Be happy to answer them. Be happy to make another video if that would be helpful for you.